Ready? Yes, no? Ready? Okay. So the last thing we need to talk about for our redox assessment is the equations. This is the final thing that we need to do to get us up to merit or excellence level, and I'll show you guys the difference. Again, it's very similar in the sense that the jump from achieve to merit is quite big, but then the merit and excellence is quite small. So I'm just going to write that. Remember that the blue stuff that I've written on this paper is in the merit level. So you need to have the red stuff plus the blue stuff in order to get the merit. Last lesson, we talked about using oxidation numbers to help us identify oxidation and reduction, and also using that to help us figure out how many electrons were gained or lost. That's really helpful for us because now we can start using that information for our equations. The first couple of equations that I'm going to show you are going to be quite easy and straightforward, and then the last one I'll show you is the more complex one. So there are all multiple steps when it comes to balancing the equation. The first step that I'm going to do is I'm going to check the active element that's being oxidized or reduced to make sure it is balanced on both sides. So for this first equation, the magnesium, I see that it's 1 and 1, so it's already balanced. The second equation that we're looking at here with the hydrogen, we see that's 2 and that's 1. So I need to fix that and balance that. So the way I do that is by adding coefficients, and I add coefficients to the front. So since this is 2, the number in front of here should also be 2. So that's the first step of what I'm doing when I'm looking at these half equations. These are referred to as half equations because I'm showing the redox half and the oxidation half. The next couple steps will not apply for these two equations because these are what are deemed as simple equations. So that will be balancing for oxygen and balancing for the hydrogen components. So I don't have to do the next two steps. So I move on to the step after that, and that is balancing the charge with the electrons. So I need to think about gaining and losing electrons, and I want the charge on both sides of the equation to match. Remember that when we add electrons, they are negatively charged. So this currently has no charge on this side. This has a charge of positive 2, so I want to bring this number down to 0. The way I'm going to do that is by adding 2 electrons to the product side. And now that brings that charge down to 0. So now these two match. That also matches what we said in the bottom half with our justification. 2 electrons are lost, and we see that 2 electrons are lost because they're on the product side, and they're now going to go to the reduction half of the equation with the hydrogen. Are we okay with that so far? All right. So in this case here, I have a positive 2 charge because each hydrogen has a positive 1. This has a 0 because it's a molecule. So I need to add electrons on this side to balance this to 0. I'm going to be adding 2 electrons to do that, which makes sense because these 2 electrons here have gone basically over here to then reduce the hydrogen to the hydrogen gas. Are we okay with that so far? And again, it matches what I say over here. 1 electron is gained. Now be mindful, we're talking about one of the hydrogen ions, and since I have 2, there's 2 total that have been gained. We good? Those are my half equations. That's what I need to do for merit. And then for excellence, you have to put them together. And that's not too bad considering, you've done all the other steps. What I need to check when I'm putting my equations together is if the electron numbers match. If they do not match, I need to do some multiplication so that way they do match. In this case, they both match. They're 2 and 2. I can see where my arrows are lined up, and I can see that they're on opposite sides, which is what I want because it means the electrons are canceling out. So we cannot create or destroy matter. We got to keep track of all the matter that's there. And that works out because the electrons lost here are gained over here. I then put the whole equation together. So I have 2H plus Mg makes Mg2 plus H2. That is my full equation. And that is the excellence, which is what I've written in green. Cool. That one's pretty easy. I'll show you a harder one. All right. Just because I do get this question every so often, people ask, does it matter the order that I write things in? No, it just needs to be on the right side of the equation. So if you put the magnesium first and then the hydrogen ion, I'm not going to mark you down for that. Cool. So that is our excellence. Other thing to check is making sure you have the positive and negatives on the right side of the number. Remember, it goes after the number when we're referring to charge, but before the number when we're referring to oxidation number. That is something I will be checking. All right? It's important for our language. Okay, second example that we had. This one's going to be a little bit more complicated because we are dealing with something that does have an oxygen. So just as a reminder, merit I'm writing in blue. Excellence is going to be in green. All right, so let's do the one that's the easy one first, which is our iron. We have iron 2 going to iron 3. The first thing I check, are the ions balanced? 1 and 1, so yes, they are. Remember, this is referring to charge. That's why it's really important that you're writing your coefficients and subscripts in the right spot, because all of this is chemistry information, this is chemistry language. So when I write this 2 at the bottom here, that's talking about the number of hydrogen. When I write the plus sign at the top or the 2 plus at the top, that's referring to charge. All these little small details in chemistry are really important because it gives us a lot of information. So chemistry itself is a language. So when I look at this guy here, I don't see any subscripts on the bottom. So that tells me there's only one. There's one on each side. I look at the superscript. That tells me charge. So I see that this is a positive 2 and that's a positive 3. I want to add electrons to the higher of the two numbers to bring it down to match this number here. So this is 3 and that's 2. So I'm only going to be adding 1 electron. So that way that balances. Oops. I don't want it on that side. Yes, you're right. Okay. All right, let's double check with what I've written below. So I've identified this as the oxidation reaction. I've identified it as losing 1 electron. And I can see in that equation up there, they have lost 1 electron. It's on the product side. So product side is showing loss. Again, it doesn't matter if you write the reduction reaction on the top and the oxidation reaction on the bottom. I just need both reactions. Are you okay with that so far? All right. This now is going to get a little bit trickier. So we're going to have to watch all the steps that I'm adding. So start from the first step again. Manganese is the active component because that one is the one that's changing its oxidation numbers from +7 to +2. So I check to see if that's balanced. I see I have one manganese here and one manganese here. So those are balanced. So that is ticked off as my first step. My second step, because this is now a polyatomic ion, is I need to balance for the oxygens that are there. Okay? The way we balance for oxygen is by adding water. So I'm going to be adding water onto this side of the equation because the oxygen's on the reactant side. So I'm going to add H2O. And I need to make sure that the number of the oxygens match. So this is 4, and that's now 1. So I put a coefficient in front. I am putting a 4. Make sense? All right. After I do that step, I now need to balance for the hydrogens because I've now introduced another element onto my equation. The way I'm going to balance the hydrogens is by adding the hydrogen ion, and this is going to be added to the opposite side of the equation, so that way it's accounted for. So I'm going to be adding H plus here, and if I look, I see that there's 2 hydrogen molecules for every water molecule, and I have 4 water molecules. So 4 times 2, 8. So I've accounted for those. All right. Are we okay with that? Okay. Final thing I'm doing is I'm balancing for the charge. We're doing the electron additions to it. Now be mindful we're thinking about the total charge that we see on both sides and bringing the higher number down to match the other side. So in this side, I have +8 because of the 8 hydrogen ions, -1 because of the permanganate providing a -1. So this is currently +7 on this side. On this side here, the manganese is a +2. water has no charge, so that's 0. So I have positive 2 on this side. Actually, I should put it as a charge and not as a oxidation number. Sorry, guys. Do we see that? All right, so basically I want to bring the 7 down to 2. And the way I do that is by adding electrons, and I will add 5 electrons. Which should match what we have in our justification over here. Oxidation number is decreased by 5. We've gained 5 electrons. The equation is showing addition of 5 electrons. So the nice thing about this is that there's lots of ways to idiot check yourself. Yeah? Okay, last step. Let's put it together. This is now the excellence. So I want to put these two equations together. I'm checking to see if my electron numbers match. They currently do not match. This is one that is 5, so I want these to be the same number. The closest number I can get them both to is 5. So I'm going to multiply this bottom half of the equation by 5. So if I multiply this by 5, everything gets multiplied by 5. So there's 5 iron 2s, there's 5 iron 3s, there are now 5 electrons. I've multiplied by 5. That's what I was doing. Now I check. My electron numbers match, so those two guys can cancel out. The other thing I can now check to see if it cancels out are the hydrogens and the waters, just because if I have two equations that are complex, we call these guys a little bit more complex, I can cancel them out if they're on opposite sides. So hydrogen ions on the left, none on the right, so those 8 stay there. Water molecules on the right, no molecules of water on the left, so those stay there as well. Now I just copy everything down. So I have 8 hydrogen ions plus the permanganate ion plus 5 iron 2s. Oops, make that 5 bigger. And then on this side, we have the manganese ion plus 5 iron 3s plus 4 waters. And that's how I put it together. Any questions? Do you guys need some more examples? Yes? Okay. What I'll do is I'll pass out the booklet that I have for the equations. I'll flick through it and I'll try to find some that would be good examples that are a little bit harder because I think these guys are pretty easy. Cool. All right. Let's do that. Oh, did I not get you one? Yeah. Oh, sorry. All right. Okay. I'll do a couple of examples from the SciPad, just so you guys have an idea of how to do the different sections. This first page is just an introduction to redox, and just identifying things that are oxidant and reductant. Do you guys want me to do one of these equations here? Or should I just skip this? Because I think you guys might be able to figure this out on your own. What do you think? Skip it or do something? Do something? Okay. I'll skip all this terminology stuff because this is just vocab, but what I'll do is I'll show you guys some of the equations. So here I have zinc and here I have fluorine, the element. Let me get my resource sheet so that way we can see the oxidation and reduction. Try to figure out what's going on here. Actually, I'll grab the bigger one so that way we can actually have the oxidation rules. All right, so when I look at these two guys and I check the rules for my oxidation numbers, both of them are in the elemental form, so they both are 0. So I'm just making a note that these guys are 0, so that way I can figure out oxidation and reduction. The next thing I need to do is figure out what the potential products are. So if I look, I see zinc at the bottom, and I see the only other option for me for zinc is the zinc 2 ion. So that's one of my products, Zn2+. The other thing I'm looking for is fluorine, who hopefully I have on this list. No, I do not, because I did not think that through when I put it up. Okay. Fluorine acts like the chlorine, so the fluoride ion is F-. So these guys are all becoming their ions. The oxidation number of this one is going to be +2 because it matches the charge. This one's going to be -1 because, again, it matches the charge. So I'm just making a note of the oxidation numbers down here, so that way I know how things are changing and I can identify oxidation and reduction. The other thing I can do when I'm looking at this equation is balancing, and I see my zincs are balanced, but my fluorine and fluoride are not. I see there's a 2 after the fluorine, so the fluoride needs to have a 2 in front, because remember, we only add atoms in coefficient form. We good? All right, identifying which one's oxidized and which one's reduced, I'm checking the oxidation numbers. So I see zinc has gone from 0 to +2. Is that oxidation or reduction if I gain or increase in my oxidation numbers? Oxidation. So increased oxidation number is oxidation. Loss of electrons is oxidation as well. So you're right, electrons have been lost because we see that we have gone from having no charge to a +2 charge. So that tells me it's lost 2 electrons. I see the oxidation number has increased. So the oxidation, which reactant has been oxidized, that is the zinc. And then that means when I go on the flip side, fluorine has an oxidation number of 0. Fluoride has an oxidation number of -1. So the oxidation number has decreased. I can see that it's also gained an electron because now it's got a -1 charge. So Fe2. We okay with that? All right. So this first page is just introduction and a nice little recap on vocab. Next one, so you guys can see how the various pages work. All right, this one here is just having you practice half equations, and they're just having you do simple half equations. So you're looking at metals, and you're looking at the non-metals. So for example, in this case, oxidation of metals, we're thinking about going from the element and its oxidation number being 0 to some sort of charged ion, and then noting how many electrons have been gained or lost. So for example, with the zinc, I see there's the zinc metal, zinc ion, it must have lost 2 electrons to do that, and I'm just filling in the blanks basically. The next one down, we have the metal ions going back to the metals. So we're thinking about them gaining electrons and going back to the elemental form. So for example, sodium has gained an electron. It's becoming the sodium element. So that's all we're doing with those. Are we okay with that? You guys see it okay? All right, these ones are my non-metals, so be mindful the non-metals are molecules and they come as a pair. There's 2 atoms attached. Okay, cool. So in this case, we were going from bromine to bromide, so Br minus. Mindful that we need to balance the active component, so that's 2 and that's only 1. So we add our coefficient in front of 2. And then the last thing we do is we add our electrons. So in this case, we have a gain of 2 electrons, 1 for each bromine atom. Questions, concerns, comments? Okay. And this bottom one here is just a shorthand to test your skills. So making sure you can identify the reactant and the product and whether or not it's oxidation or reduction. So since I'm starting with the calcium metal, it's going to produce the calcium ion. And I'm putting the state down because apparently they want states too. In this case, I see that it's gone from a 0 to a +2. So the oxidation number is increased. So that is oxidation. So that's what they want you to do on that one's there. Okay? Do you guys want me to pause here and you guys can work on those first 2 pages and then I can pick back up and show you some of the other ones? Yeah? Okay, let's do that. Cool. Yeah, let's do that. It's a good place to stop. All right. Year 12, let's keep going because I want to make sure you guys can do some of this for homework. So you guys have made somewhat of a dent on these first 2 pages. I do want to talk about the next page, so page 104, because that means that you guys can do 104 and 105. In fact, you guys can do all of these pages after I cover what is here, but I'm mindful you guys probably want me to do some examples of those other pages when we get to it, but I want to pace myself and pace you guys so you're not overwhelmed. But I do want to show you guys, like, model-wise what you need to be doing for these questions. So I just want to do the next kind of section so that way you guys can work on it if you choose. All right, so this one here on page 104 and 105 are looking at the more complex half equations. I did do one in that example from the assessment template, but I'll do another one here so you guys can start to get used to it. So this one here, I'm just going to copy it down so that way we have more space to work. So you have, in this case, dichromate and chromium. And we're going to go through the steps of balancing and figuring out electrons and things like that. The active component in this is going to be the chromium the chromium element. I see on this side that there's a subscript of a 2 and there's nothing on this side. So this is not currently balanced. I'm going to then put a coefficient in front of the chromium ion to balance that, and that's going to be the number 2. So the 2 goes there. So that's step number 1. Step number 2 then, I'm just going to change colors so you guys can think of the steps, and I'm going to put it in rainbow order. Step number 2 is to then balance for the oxygen. I see that this is a 7 for the oxygen, and I do that by adding water, H2O. Since this is a 7, this means that the coefficient in front of this this water needs to be a 7 as well. Cool. All right, next step after that is I want to balance for the hydrogen ions. I might actually switch to green because I think the yellow is a little bit hard to see sometimes. So the way I do that is by, actually let me circle these. So this one's the red step. This is step number 2. Step number 3 then is to add the hydrogen, and I do that by adding the hydrogen ions. So I'm going to be adding it to this side of the equation. And I see that this is 2 and that's 7, so that's 14. So I'm adding a 14 in front here. So that's step number 3. Last step, check the charges on both sides and then add the electrons to the higher side. So this has 14. That is a negative 2. So total charge on this side is going to be positive 12. On this side, that is positive 3, and I have 2 of them. So I have positive 6 on this side. Water is providing nothing, so that is 0. So that's 6 and that's 12. So I'm comparing those 2 numbers. So I need to bring this number down to 6. And the way I do that is by adding the 6 electrons. And that's step number 3. I see that the electrons are on the, hopefully I can make it. I see that the electrons are on the, so we see that the electrons are on the reactant side, so that tells me that the chromium has gained the electrons, so this gaining of electrons is a reduction reaction. If I want, I can double check this with the with the oxidation numbers. So I'm just going to do that in pink. So chromium in this case, if we were doing the oxidation math, is we have 2 chromiums and 7 oxygens, making a negative 2. And if I was, I should say the chromium ion, Cr2O7, 2 minus, That'd be 2x plus negative 14, because that would be 7 times 2 equals negative 2. And then I add 14 to each side. If I want to double check, that's 12. And now I divide by 2. So I get the chromium is 6 over here. And then on this side, it is positive 3. So you see again, the oxidation numbers has decreased. And that's also verifying that I have a reduction reaction. Do you guys need to see another example? Yes? Okay, let me go grab my charger so the computer doesn't die. Look at that! Didn't lose it. Nice. It just went into some sort of protective sleep mode. Yeah. Do you guys want to do the second one to try? Or should I do the one? Okay. All right. So let's do the same sort of steps. We will copy that down. So I am going to be doing that. All right. So that's my reaction over there. And what I'm going to do is, again, the step-by-step process of trying to figure out what's happening with the equation. Do you guys want me to give you a crash course in the oxidation numbers so we can figure out oxidation and reduction? Yeah? Okay. So if I look at my rule sheet, let's grab that again. What I want. And I want a piece of paper. Oh, let me get it. Ball and paper. We're on the third page. All right. So let's just do a quick kind of crack in the oxidation numbers so we can figure out if it's oxidation or reduction. It's also a good way to verify to make sure that we've done our equations correctly. So, thank you. When we're looking at the rules over here, hydrogen is on my list. And it says hydrogen in compounds has a charge of +1, with the exception of if it's in a metal hydride. In this case, when I look at it, that's not anything that's a metal there, but it is hydrogen in a compound. So this one would have the oxidation number of +1. On this side here, we see again the hydrogen's in a compound. It is not in a metal hydride, because none of these are metals. So that one is also +1. So no change there. So that's not part of my redox reaction. What are you doing? You just closed the camera for no reason. Okay. Next one we will skip is phosphorus, because phosphorus is not on my list, so that's probably going to require oxidation math. I'll go to the oxygen instead. Oxygen I know is listed. If it's in a compound, it is -2. If it's in any sort of peroxide, then it's -1. Or if it's with fluorine, it's +2. So I can see when I'm looking at this guy over here, this isn't in a peroxide. It is in a compound, so this is -2. And the oxidation number for the oxygen on the other side is still -2. We good? All right. Phosphorus is the last one I use. Phosphorus is not on my list as a specific rule, so I need to do oxidation math to figure that guy out. In the first one here, I have my H3PO2, and I want to figure out what the phosphorus is. So I can use the final rule here. Oxidation numbers in a molecule sum to 0. So basically, if I know the oxidation number of hydrogen and oxygen, because the total equals 0, I can figure out phosphorus. So the theory is that the 3 hydrogens plus the phosphorus plus the 2 oxygen oxidation numbers, when they're added together, is going to equal 0 based off of that final rule. I then substitute in my numbers. So I have 3 times positive 1 plus my unknown, that's x, plus 2 times negative 2 equals 0. Let me just focus that again. So I have positive 3 plus x plus negative 4 equals 0. When I add those two numbers together, I have x minus 1, or you can say x plus negative 1 equals 0. I add 1 to both sides to cancel the 1's out. Remember, you're doing the opposite of whatever you need to do to cancel out things. So I get the phosphorus is equal to positive 1 as the oxidation number. So this guy is positive 1. We good? All right, second one. So we have 3 hydrogens still, the 1 phosphorus, but now we have 4 oxygens. So H3PO4. Again, we can assume that this equals 0 because oxidation numbers in a molecule add together is 0. So I have 3 hydrogens plus the phosphorus plus, in this case, 4 oxygens equals 0. And we plug in the oxidation numbers that we know. So we have 3 times 1 plus the unknown of x plus 4 times negative 2 equals 0. So I have 3 plus x plus negative 8 equals 0. I have x plus negative 5 now because the negative 8 plus the 3, and then plus 5 to both sides to cancel out the negative 5. So I have x equals positive 5 in that case. Cool. So this guy over here is positive 5. So looking at those oxidation numbers, I can see that phosphorus has gone from 1 to 5. So that's an increase in oxidation numbers. So that tells me oxidation. And when I do my half equation, it should also have the same result. It should also have 5 electrons being lost when I do this math. So I can verify and idiot check myself. All right, half equation time. Ready? Okay. So going through my steps, we are going to be balancing first for the phosphorus to see is the phosphorus balanced. I can see that that's a 1 and that's a 1. So is the phosphorus balanced? Yes, phosphorus is balanced because they're both 1. All right, step number 2 then is I need to add the water to balance for any extra oxygens. I see 2's over here and I see 4 over here. So those are not balanced. I'm going to be adding water. Am I adding it to the left or the right? To the left, because there's 4 on this side. How many I'm going to add? 2. So now I have 4 oxygens on this side and 4 oxygens on that side. All right, step 3 is adding the hydrogens. I can see that these hydrogens are balanced because it's 3 and 3, but I see that this has 4. So I need to add an extra 4 onto the right-hand side. I add them as the 4 hydrogen ions. Keep going. All right, last step is to add my electrons. I notice, whoopsie, on this side I have 0 as my charge because both of those are molecules. So 0, 0, this one's 0, and I have positive 4 as my charge on that side. So I need to bring this guy to 0. How am I going to do that? By adding electrons. I am adding how many? 4. And again, it confirms what we said earlier with the oxidation numbers. We've lost electrons, so this is oxidation. The other thing that I can check is that my oxidation number has gone from positive 1 to positive 5. That is a difference of 4, which makes sense because there's 4 over here. This is what I'm saying. This assessment's really good at idiot checking yourself. Because all of these numbers should match up. Yeah? All right. Bell's going to go in about 2 minutes. I'm going to stop here. What I would suggest you guys do at this point, because we're going to need multiple lessons on this, is aim to get up to page 5 done. The nice thing is that I have double-sided it, and you can like rip it off as you hand in, so you don't have to hand in the whole booklet at once. You can hand it in as you go to get your answers checked. But there is that QR code. You can always check it there as well. Okay?